Something moved in the darkness between the stars. Not a planet, not a comet, not a dying star. Something that curved, accelerated, and glided through the void with what scientists could only describe as purpose. And the only machine in the universe close enough to detect it was a 47-year-old spacecraft running on technology older than most of the people now desperately trying to understand what it found. If that does not make the hair on the back of your neck stand up, what follows absolutely will. Hit subscribe or right now because this is the kind of story that does not come around twice. And you are going to want to be here when we cover what happens next. Voyager 1 is unlike anything else humanity has ever built. Not because it is the most powerful, not because it is the fastest, but because it is the furthest. Right now, at this very moment, this small spacecraft, roughly the size of a compact car, is drifting through interstellar space, the vast, cold, almost unimaginably empty region that exists between star systems. It crossed out of our solar system's boundary zone years ago, becoming the first human-made object in history to enter the space between the stars. No other machine we have ever launched has traveled as far. No other piece of human engineering has ever been so completely, so profoundly alone. Voyager 1 launched on September 5th, 1977. To put that in time, the original Star Wars had just hit theaters a few months earlier. The personal computer did not yet exist in any meaningful form. The engineers who built Voyager used slide rules alongside their early computers. They designed it, built it, and sent it into space with the genuine expectation that it would study Jupiter and Saturn and then drift off into silence, its mission complete, its power fading sometime in the early 2000s. No one seriously believed it would still be transmitting decades later. And yet, here we are. Voyager 1 has now traveled more than 15 billion miles from Earth. That number is almost impossible to hold in your mind in any meaningful way. Think of it this way. The speed of light, the absolute fastest anything in the known universe can travel, is approximately 186,000 miles per second. Even at that speed, a signal sent from Earth to Voyager 1 takes about 22 hours to arrive, and then you wait another 22 hours for the response to come back. Every single command, every single instruction, every single question engineers send to this spacecraft comes with a 44-hour round trip. It is like sending a letter and waiting almost 2 full days just to find out if it arrived. The instruments Voyager carries are ancient by modern standards. Magnetometers that measure the strength and direction of magnetic fields. Plasma wave sensors that listen for activity in the charged particles drifting through space. Cosmic ray detectors. Low-energy particle analyzers. All of it designed in the 1970s, built with technology that was cutting-edge then, but would be considered primitive today. The computer memory on board measures in kilobytes. Your phone has millions of times more processing power. And yet this humble, aging, quietly humming machine has become the most important scientific instrument humanity has ever placed in space. Not because of what it was designed to do, but because of where it ended up and what it has been hearing. Voyager also carries something no other spacecraft has ever carried: the Golden Record, a 12-inch gold-plated copper disc containing sounds and images chosen to represent life on Earth, greetings in 55 languages, music from dozens of cultures including works by Bach and Beethoven, natural sounds like ocean waves and thunder and birds singing, scientific diagrams, mathematical explanations. It was a message in a bottle thrown into the cosmic ocean, designed for any intelligence that might find it in thousands or millions of years. A hello from a young civilization reaching outward for the first time. What nobody fully considered at the time was the possibility that the hello might get a response far sooner than anyone expected. The story of what Voyager found begins quietly, the way the most significant discoveries often do. In the endless stream of data flowing back from the spacecraft, there appeared a small anomaly, a blip, a tiny deviation from what the sensors were to pick up. Space is not a clean environment. It is filled with drifting particles, magnetic fluctuations, faint radiation from distant stars, and countless sources of background noise. Tiny anomalies appear in deep space data regularly, and the vast majority of them turn out to be nothing at all. So, when this particular blip showed up, the team at NASA's Jet Propulsion Laboratory in California initially noted it and moved on. One of the mission specialists who first spotted it described the feeling as like shouting into a canyon for decades and finally hearing something shout back, but so faintly that you were not quite sure you had really heard it. Then the blip moved. Not the way a piece of space debris moves, tumbling and drifting, carried along by whatever momentum it picked up long ago. Not the way a natural object moves, pulled gradually by the gravity of distant masses. It curved. It changed direction in a smooth, deliberate arc. It accelerated. These are not things natural objects in deep space do. A rock does not decide to turn. A cloud of dust does not accelerate in a specific direction. In the physics of space, objects follow the rules laid down by gravity and momentum, and they do not deviate from those rules unless something is actively acting on them. What Voyager's plasma wave sensors had detected was actively defying those rules. One of the system's analysts studying the data described the movement as similar to watching a drone rather than a rock. It had what he called intention. That word intention is an extraordinary one to use in a scientific context. Scientists are trained to be careful with language to avoid projecting purpose onto natural phenomena, but the data kept pushing back. The object's behavior could not be modeled using any known natural process. It was not responding to gravitational influences in any expected way. It was not decaying in its velocity the way an unpowered object would. It was moving, and it seemed to be moving because something was making it move that way. As this data was being processed and analyzed, the team was working through the standard checklist that scientists always use when something unexpected appears. Could it be a previously unknown small moon? Too small and moving wrong? A comet? No tail, no ice signature, no heat trail from outgassing? A new type of asteroid? Asteroids do not change direction mid-flight. Space dust? Dust does not accelerate in a straight line. One by one, every natural explanation available was tested against the data, and one by one, every natural explanation failed. The team ran simulations. They modeled every known type of object that might exist in interstellar space and compared each model against what Voyager's sensors had actually recorded. Nothing fit. The object's path bent in ways that contradicted every orbital behavior pattern in the scientific literature. There was no drift, no decay, no deviation caused by any detectable external force. It was simply moving in a way that should not have been possible. Then came the moment that transformed this puzzling anomaly into something far more significant. Voyager 2, the twin spacecraft that had launched 16 days before Voyager 1 back in 1977 and had traveled a completely different path through the outer solar system, detected something eerily similar. Millions of miles away on a separate trajectory with separate instruments, the second spacecraft picked up the same type of magnetic fluctuation, the same kind of plasma pulse, a matching signal signature that no natural phenomenon could easily explain occurring in two different locations at the same time. This is called cross-confirmation, and in science, it is enormously important. A single strange reading from a single instrument can always be dismissed as a sensor glitch, a software error, an artifact of the measurement process itself. But when two completely separate instruments on two completely separate spacecraft in two completely separate locations in space detect the same thing at roughly the same time, the possibility of instrument error collapses. Whatever this was, it was real. It was happening in space, not inside a malfunctioning circuit board. NASA quietly elevated the classification of the event to what is known internally as a Level 3 alert. This designation is reserved specifically for phenomena that fall outside the boundaries of current scientific understanding. It is not a designation used lightly. It signals that something is happening that the available models and frameworks cannot explain. The event was real. The mathematics were consistent. The movement appeared deliberate. And nobody, not one person in the room, knew what to make of it. As more data continued streaming in across that 22-hour signal delay, the picture that emerged was not simpler. It was dramatically, almost incomprehensibly, more complex, because it was not one object. When the full telemetry logs were pulled and analyzed, when every data point was mapped and the full picture assembled, what Voyager had actually detected was not a single anomalous object moving through interstellar space. It was 305 of them. 305 objects all moving together. Not scattered randomly, not drifting apart the way a group of natural objects would inevitably do over time due to slight differences in velocity and direction. They were moving in formation, each one maintaining its position relative to the others, with a precision that seemed impossible without some form of active coordination. They glided past Voyager in what the data showed as a choreographed arc, smooth and measured and organized in a way that no natural process produces. In nature, when groups of objects travel through space together, they gradually spread out. The slight differences in their individual speeds, the tiny variations in the gravitational pulls acting on each one, all of these forces work over time to pull the group apart. The longer you watch a naturally formed group of space objects, the more dispersed they become. That is physics. It is reliable and predictable and universal. But these 305 objects were not spreading out. They were maintaining their formation across distances that should have made that impossible. Scientists who study large-scale coordinated behavior on Earth compared it to watching a flock of birds or a school of fish. Groups of individual creatures that move together as a unit, each one responding to the others. The whole formation behaving as if guided by a single shared intelligence. Except that birds and fish exist in fluid environments where they can sense each other through sound and movement and pressure changes. These objects were in the vacuum of space where none of those mechanisms exist. The only way to maintain that kind of coordinated formation in a vacuum is through technology. Running through the data from the 305 objects, scientists found something else embedded in what the plasma wave sensors had picked up: patterns. Not the random, chaotic patterns of background cosmic noise. Not the broad, slow rhythms of magnetic fields or the steady hiss of radiation from distant stars. These were tight, structured, repeating patterns. Loops and sequences and intervals that had a measured, organized quality to them. Patterns that looked to the scientists, staring at the readouts, less like nature and more like language. One researcher from Caltech described it as the signals feeling less like something the universe produced and more like something constructed. A system, a code. Not necessarily a code that humans could yet read, but a code in the sense of structured information rather than random noise. The pulses coming off these objects were not chaotic. They had rhythm. They had internal consistency. They repeated in ways that random processes simply do not. To rule out the possibility that what they were seeing was a glitch in Voyager's primary systems, the team made the decision to activate one of the spacecraft's oldest backup subsystems, a secondary telemetry channel that had not been used since the early 1990s. It was the kind of system kept dormant for emergencies, a last resort option kept in reserve in case the primary systems failed. Engineers activated it carefully, knowing that any mistake would take 22 hours to detect and another 22 hours to correct. The backup system came online. It worked, and it reported exactly the same readings as the primary system had. The same objects, the same formations, the same structured plasma pulses, all confirmed through a completely independent channel that had been sitting unused for decades. The implications of that confirmation were staggering. This was not an error in the machine. It was not a software artifact or a sensor degradation issue. What Voyager was detecting was real, verifiable and consistent across multiple independent systems, and the structured nature of the signals pointed not just to the presence of objects, but to the possibility of information, as if these 305 objects were not just moving through space, but communicating with each other, with something else, or with whatever might be close enough to listen. The method by which these objects were moving added yet another layer of mystery. Voyager's instruments are sensitive enough to detect propulsion signatures. Ion drives leave particle trails. Chemical rockets leave heat signatures. Even solar sail propulsion produces detectable effects on the surrounding environment. None of these signatures were present. There were no engine flares, no ion trails, no detectable evidence of any propulsion mechanism that human science has ever developed or theorized. Yet the Doppler shift measurements showed these objects accelerating and decelerating with precision. Some were moving faster than any object humanity has ever launched into space. According to the data, certain objects in the formation were traveling at velocities that exceeded what scientists calculate as the escape velocity of the entire Milky Way galaxy. These were not objects slowly drifting through interstellar space. They were moving at speeds that placed them in a category completely beyond our current technological reality. And they were doing it without any detectable propulsion. One theoretical physicist working on the analysis described it as not flight in any sense we understand, but something closer to gliding on a medium we have not yet learned to measure. As if these objects were interacting with the fabric of space itself in ways that allowed them to move without anything we would recognize as an engine. While all of this was being studied and analyzed behind closed doors at research institutions across multiple countries, something unexpected began happening back on Earth. Amateur radio operators in different parts of the world, people running homemade listening setups built from spare parts in their backyards and garages, started reporting unusual signals. Faint, irregular pulses with a rhythmic quality that did not match any known terrestrial radio source. On their own, these reports would have been easy to dismiss. Strange signals show up in amateur radio setups all the time due to atmospheric interference, satellite chatter, and 100 other mundane explanations. But then someone began comparing timestamps. The moments when these amateur operators had recorded their unusual signals aligned almost precisely with the periods when Voyager had been recording its most intense plasma anomalies. Something originating billions of miles away in interstellar space appeared to be producing ripples that were somehow reaching Earth's upper atmosphere and bleeding into the electromagnetic spectrum in ways that backyard equipment could partially detect. The implications of that were almost too large to process. NASA began encrypting portions of its deep space telemetry feeds. Certain transmissions were rerouted through secure relay stations. Space agencies in other countries quietly tightened their own deep listening protocols. The reasoning was clear. If amateur radio hobbyists with modest equipment were picking up fragments of these signals, more sophisticated actors with more resources and less transparent intentions could potentially do the same. The scientific story was now intersecting with questions of security in ways that nobody had anticipated. Meanwhile, a dedicated team was tasked with going back through decades of archived data from every deep space mission ever flown. Voyager 1's own historical logs were examined in detail. Pioneer 10 and Pioneer 11 data was pulled and analyzed. New Horizons data was reviewed. All of it was compared against the patterns now being seen in the current Voyager readings. The result was unambiguous. Nothing matching this phenomenon had ever been detected before. There were no echoes of it in any previous mission data, no historical precedent, no earlier encounter that had been logged and forgotten. Whatever these 305 objects were, this appeared to be the first time any human instrument had ever detected them. That absence of historical precedent led some researchers to a deeply uncomfortable theory. Perhaps these objects had always been present in interstellar space but had been undetectable, either because they were dormant or because no human instrument had ever been in the right place with the right sensitivity to pick them up. And perhaps what had changed was not their activity, but our proximity. Voyager 1, drifting quietly through interstellar space for decades, had finally reached a region where something was happening. Or perhaps, and this is the theory that made the most people deeply uncomfortable, Voyager's own presence had played a role. Its steady mechanical transmissions, its ancient analog signals pulsing outward through the dark, the golden record writing on its side, encoded with the sounds of Earth and the mathematical signature of a civilization reaching outward. Perhaps something had noticed. As scientists continued their analysis, Voyager itself added an entirely new dimension to the mystery by beginning to behave strangely. Its attitude and articulation control system, the guidance mechanism responsible for keeping the spacecraft properly oriented, began routing data through subsystems that had not been actively used in years. Not catastrophically, not in a way that suggested the spacecraft was failing, but in a way that was systematic and structured, and most significantly that had begun immediately after the passage of the magnetic pulses from the 305 objects. Engineers at the Jet Propulsion Laboratory had to dig into filing cabinets containing paper manuals from the 1970s to understand what they were seeing. Voyager's software was written in early assembly language. Some of its programming exists only as handwritten notes in the margins of documents that predate the personal computer. Every test they ran carried the weight of that 44-hour round-trip communication delay. One mistake, and you would not know about it for nearly 2 days. The engineers worked carefully, methodically, rebooting subsystems and activating recovery routines last used during the 1980s, trying to understand what was happening to the spacecraft without making anything worse. What they found was that Voyager was not failing. Its instruments were functioning correctly. Its power levels were stable. Its communication systems were operating normally, but certain new behaviors had appeared that had no explanation in any of its original programming. The spacecraft had reactivated dormant memory segments. It had rerouted certain data pathways and sequences no engineer had ever written. It was as if something external had reached into the machine's ancient architecture and gently rearranged certain things. Not destructively, not randomly, but with a selectiveness that made the idea of pure coincidence very difficult to accept. The question that kept surfacing in every conversation, in every analysis session, in every quiet moment between data reviews, was the one nobody felt fully equipped to answer. Were these 305 objects the product of some intelligence that had built and deployed them? Or were they something entirely natural? Exotic forms of matter or energy operating according to physical laws that human science has not yet discovered? Neither possibility was comfortable. If they were engineered, the questions multiplied instantly. Who built them? How long had they been traveling? Where did they come from? What were they doing? And why had they passed by without any apparent interest in stopping to investigate our solar system or communicate directly with us? If they were natural, then the universe contained phenomena capable of organized formation flight, structured signal emission, and physics-defying propulsion. And we had been completely unaware of any of it until a 47-year-old spacecraft happened to drift into the right place at the right moment. There is something worth sitting with in that last thought. Voyager 1 is our oldest active spacecraft. It runs on technology that the modern world would consider laughably primitive. Its computer memory is smaller than a single photo on your phone, and yet it may have just witnessed something that our most advanced modern instruments have never seen. Some scientists began wondering whether that primitiveness was actually an advantage. Modern spacecraft are electronically busy, filled with high-frequency digital systems constantly transmitting and receiving, generating their own electromagnetic noise. Voyager is quiet, slow, analog. It has no clutter, no broadband static, no busy digital chatter filling its sensors with noise. It is just out there in the cold dark, listening the way a person standing alone in a silent field can hear things that someone in a city never could. Perhaps Voyager did not stumble into this discovery despite being old. Perhaps it made this discovery because of it. A perfect ear tuned by decades of silence sitting in the deepest, quietest place a human machine has ever reached in exactly the right location when something extraordinary passed through. And what it detected has left the people studying its data with a question that will not let them rest. Something moved out there in the darkness between the stars. It moved with purpose, in formation, at speeds beyond our comprehension, without any propulsion we can identify, sending signals with a structure that looks more like communication than noise. And then it was gone. All 305 of whatever they were vanishing back into the interstellar dark. Somewhere out there, Voyager is still listening, still transmitting its ancient signal back across 15 billion miles, still carrying that golden record with its encoded hello from a small civilization on a pale blue dot. The universe heard us reach out, and something, somewhere, may have reached back. Let us go back to the beginning of this story, because there is a detail about Voyager's journey that most people do not fully appreciate. When Voyager 1 launched in 1977, it was sent on what scientists call a grand tour trajectory. The alignment of the outer planets at that particular time was extraordinarily rare, a configuration that allowed a spacecraft to use the gravity of one planet to slingshot itself toward the next, gaining speed with each flyby without burning additional fuel. Jupiter came first. Voyager flew past it in March 1979, capturing the first close-up images of the gas giant's swirling storm systems and discovering active volcanoes on its moon Io. The images were unlike anything scientists had ever seen, a world of fire orbiting a world of storms, both of them utterly alien and both of them real. Then, Saturn reached in November 1980, where Voyager's cameras revealed the extraordinary complexity of that planet's ring system in detail no Earth telescope had ever come close to matching. The rings were not simple and uniform. They were braided, structured, containing gaps and waves and shepherding moons that kept their edges sharp. Again, a reality more strange and more beautiful than anyone had anticipated. After Saturn, Voyager 1 was on its final trajectory. Unlike its twin Voyager 2, which continued on to visit Uranus and Neptune, Voyager 1's path after Saturn carried it up and out of the plane of the solar system. It was heading for the edge, and everyone knew it. What nobody fully knew at the time was what it would find when it got there. The boundary of our solar system, the region where the sun's influence fades and the interstellar medium begins, is called the heliopause. It is not a sharp, clean line, but a complex, turbulent transition zone where the solar wind, the constant stream of charged particles flowing outward from the sun, finally loses the battle against the pressure of the interstellar medium pushing in from the other direction. Voyager crossed this boundary and entered true interstellar space, becoming the first human-made object in history to do so. That crossing itself produced surprising data. Scientists had models for what the heliopause would look like based on theoretical calculations and indirect observations. The actual boundary was different from what those models predicted. The magnetic field orientation changed in ways that surprised researchers. The density of cosmic rays and the composition of the particle environment shifted in patterns that did not perfectly match expectations. The universe once again turned out to be more complicated than our best models had suggested. And Voyager, our humble 47-year-old emissary, was the instrument that revealed the discrepancy. This is actually a pattern throughout Voyager's history. Everywhere it has gone, it has found things that were not quite what scientists expected. Jupiter's volcanic moon Io was not expected. The complexity of Saturn's rings was not expected. The turbulent, asymmetric structure of the heliopause was not expected. And what came next, what the spacecraft sensors detected drifting through the space between the stars, was most certainly not expected. The universe has a habit of rewarding exploration with surprise. The further you go, the more you discover that your maps were incomplete. The 305 objects that Voyager detected were not simply there and then gone in an instant. The encounter played out over a period of time long enough for the spacecraft's instruments to build up a detailed picture of what was happening. The plasma wave sensors recorded how the environment around Voyager changed as the objects passed. The local density of charged particles fluctuated in ways that were clean and measured, not chaotic. The magnetic field around the spacecraft warped in response to the presence of these objects, bending in patterns that looked to the scientists analyzing the data less like a natural disturbance and more like a controlled effect, as if the objects were not just moving through the surrounding medium of space, but actively shaping it, using it, interacting with it in some purposeful way that went far beyond simple physical displacement. The scale of the formation also became clearer as more data was processed. These were not small objects passing close to Voyager. The geometry of the encounter, worked out from the timing of the readings and the distances implied by the signal strengths, suggested objects spread across a region of space far larger than anyone had initially assumed. A formation of that size, maintaining that kind of coordinated structure over that kind of distance, implied a level of precision that stretched every natural explanation to its breaking point and beyond. There is another dimension of the story that deserves attention: the emotional dimension. The scientists and engineers who work on the Voyager mission are almost without exception people who have devoted significant portions of their lives to this spacecraft. Some of them were young researchers when Voyager was at Jupiter. Some of them inherited the mission from the generation that came before them. Some of them have spent their entire careers listening to the slow, patient signal coming back from the most distant human object in universe. When strange data started coming in, their reaction was not simple excitement. It was a mixture of wonder and discomfort, and a very profound sense that the ground beneath their feet, not literally, but intellectually, had shifted in ways they were not entirely prepared for. One of the things that makes science work is the willingness to follow data wherever it leads, even when it leads somewhere uncomfortable. The scientists working on this encountered data that did not fit. They tested every alternative. They looked for errors. They checked the instruments. They pulled in backup systems. They compared notes across agencies and countries. And the data kept coming back pointing in the same direction. Something was out there. Something that moved differently. Something that organized itself. Something that produced structured signals. Something that left Voyager itself behaving in ways it had never behaved before in nearly 5 decades of operation. Whatever it was, it chose this moment. This particular window in time, when a spacecraft launched by a young civilization decades ago finally drifted far enough from home to reach the space where it was traveling. Whether that timing was coincidence or not is a question nobody can answer yet. But it is a question that once you have heard it, is very difficult to stop asking. We sent a golden record into the dark with a message that said, "We are here." And something in the dark between the stars may have just sent something back. The stars are not empty. The space between them is not simply a void. Something moves through that darkness on paths we have only just begun to trace, at speeds we cannot yet match, in formations we cannot yet explain, sending signals we cannot yet fully read. And right now, drifting quietly through that same darkness, our oldest spacecraft is still out there, still listening, still transmitting its faint signal home across 15 billion miles of silence, one pulse every 22 hours, faithful and patient as the day it was launched. Whatever comes next in this story, Voyager will be there when it happens.